Hi guys and lecturer as well. My name is Sanjeev Raj Anaki Saravanan and my student ID is 01DKM21F1046. Now let's look at the introduction of vector and scalar. Mathematicians and scientists call a quantity which depends on direction a vector quantity, and a quantity which does not depend on direction is called a scalar quantity. Vector quantity is a quantity that has both magnitude and direction. Examples of vector quantities are displacement, velocity, direction, momentum, force, lift, weight, and etc. Scalar quantity is a quantity that has magnitude only. Typical examples of scalar quantities are time, speed, temperature, and volume. A scalar quantity or parameter has no directional component but only magnitude. When comparing two vector quantities of the same type, you have to compare both the magnitude and the direction. For scalars, you only have to compare the magnitude. When doing any mathematical operation on a vector quantity, like adding, subtracting, or multiplying, you have to consider both the magnitude and the direction. This makes dealing with vector quantities a little more complicated than scalars. Now let's look at the operation of vectors. For addition and subtraction, we can use two methods, which are parallelogram method and construction method. In order to find sum of two vectors, we can use triangle law or parallelogram law of vectors. As you can see, the picture in the first column represents triangle law, and this is how triangle law works. The second picture in the second column represents parallelogram law. Moreover, properties of scalar product. There are totally 6 properties of scalar product, or also known as dot product. The example questions based on the properties of scalar product will be explained later in this video. In addition, angle between two vectors. In order to find angle between two vectors, we can use the formula cos theta equals to vector A times by vector B divided by modulus vector A times by modulus vector B. Furthermore, properties of vector product. As you can see, there are totally 5 properties of vector product, and the example questions will be explained. Besides that, area of triangle and parallelogram. In order to find the area of triangle and parallelogram, we can use the respective formulas. The first formula is to find the area of triangle, and the second formula is to find the area of parallelogram, which is we do not have to divide by 2. Okay, now let's look at example question 1. We have chose vector and scalar in architecture, which will be explained later by my group member. Okay, as you can see, there are 2 pictures with the same architecture, one without marking, another one with marking. This is for a better understanding of what we're going to find, which is we're going to find the area of the front face of the roof, or the area of the triangle of TUV. Okay, the value of TUV are given below. First of all, we should mark the value of T as OT, U as OU, and V as OV. This is to make it clear and easy when you're performing solutions or calculations. Now let's look at the solution. In order to find the area of triangle TUV, we need to know the formula, which is 1/2 modulus product vector TU and vector UV. Okay, the first procedure is to find the value of vector TU. In order to find the value of vector TU, we need the value of vector TO plus by vector OU. Since we already have the value of vector OU, we can just straight away substitute. However, we do not have the vector TO, but we do have the vector OT, so we're going to change the direction. In order to make this possible, we're going to multiply OT with negative. Once we did that, we can get the value of vector TO, which is -2, -7, and -9. Okay, the next step is to add the values from their respective unknowns. Now I will explain how this one works. -2 on vector TO and -3 on vector OU represents I. -7 on vector TO and 4 on vector OU represents J. -9 on vector TO and -1 on vector OU represents K. Now we can just add the values from their respective unknowns. Once we did that, we can get the value of vector TU, which is -5, -3, and -10. Okay, the second procedure is to find the value of vector UV. In order to find the value of vector UV, we need the value of vector UO plus by value of vector OV. Since we already have the value of vector OV, we can just straight away substitute. However, we do not have the value of vector UO, which is the same case as the previous solution. But we do have the value of vector OU. So we're going to change the direction, and to make this possible, we're going to multiply OU with negative. Once we did that, we can get the value of vector UO, which is 3, -4, and 1. And the next step is same as the previous solution, where we find the value of vector TU, which we have to add the values from the respective unknowns. Once we did that, we can get the value of vector UV, which is 6, -5, and 5. Thirdly, we're going to find the product of vector TU and UV. As you can look at the solution, first what we're going to do is, we're going to cut the column and row of I. The remaining values are -3, -10, -5, and 5. And now we're going to perform cross product. So -3 times by 5 minus -10 times by -5, and this represents I. And secondly, we're going to cut the column and row of J. The remaining values are -5, -10, 6, and 5. Cross product, -5 times by 5 minus -10 times by 6, and this represents J. And thirdly, we're going to cut the rows and column of K, and the remaining values are -5, -3, 6, and -5. We're going to perform cross product, -5 times by -5 minus -3 times by 6, and this represents K. And finally, we're going to subtract the values starting from I, and the answer that we can get for the product is -65I minus 35J minus 43K. Now we have found the product of vector TU and UV. We can just substitute the value into the formula of area of triangle. Once we did that, we can get the answer for the area of triangle TUV, or the area of the front face of the roof, which is 42.72 units square. I hope that you can understand how the formula of area of triangle works in vector and scalar. Moreover, further questions will be based on properties of scalar product, properties of vector product, area of triangle, area of parallelogram, and angle between two vectors, which will be explained by my group members. Thank you.
Hi, my name is Naresh, son of Virasamy. I'm from DKM 1B. My matrix number is 01 DKM 21F1071. Before going with my presentation, I would like to greet good morning to my engineering mathematics lecturer, Madam Intan Faradina, and to my fellow classmates. Today, I would like to present about a real life application of vector and scalar and a question related to vector and scalar. Let's go to the slides. In 21st century, application of vector and scalar calculation are widely used in many sectors. One of the sectors that use vector and scalar calculation frequently is architecture. For instance, to build a building, developers is using vector and scalar to calculate the magnitude and direction accurate and precise according to the plan. Not only that, many application developers are also applying vector and scalar calculation in their app. Example apps are Google Maps and Waze. The reason behind using vector and scalar calculation in their apps is to calculate and produce an accurate direction to the users. Moreover, in aviation, pilots are also applying and using vector and scalar calculation to calculate magnitude and direction to take off and land at exact position and place. Thus, even though we are living in technology evolved era, but still vector and scalar calculations are playing major role in many situations. Next, let's see question related to vector and scalar. So today I would like to discuss how to find the angle between two vectors and also unit vector. So the first question is, find the angle between A and B vector if A vector is 5i minus 2j plus 8k and B vector is 4j plus 3k. So to find answer for question A, you need to use the formula of cos theta equals to vector A times vector B divided by magnitude A times magnitude B. So first you need to times vector A and vector B. So first separate it into groups and divide it times it with groups. So as example, 5i times 2i and negative 2j times 4j and 8k times 3k. So this we will get answer 26, and right now we will find magnitude of A. So to find the magnitude A, you need to square 5 you need to square the vector A with square root 2, and also for magnitude B you need to use the same concept. This you will get the answer square root 93, and for the B you will get square root 29. So you need to fill up the answers which we get into the formula, which is cos theta equals to vector A times vector B divided by magnitude A times magnitude B. So this the final answer will be 59.93 angle. Right now we will see how to find unit vector for vector B. So for unit vector B, we need to use the symbol like I have shown in the question B answers, in the calculation I mean. So first you need to first vector B divide by magnitude B. So before this itself, in question A we already find magnitude B. So just fill up the answer in this. So convert the solve the square root and you will get the answer 5.385. So just you need to separate it into groups, which is 2 divided by 5385 I plus 4 over 5.385j plus 3 over 5.385k. Thus the final answer will be 0.371i plus 0.743j plus 0.557k. That's all. Thank you.
Hello, my name is Muhammad Riza bin Kamar. My matrix number is 01DKM21F1042. Today, I want to explain about the question. Number one question is scalar product. For the formula, we are going to use A times B equal to A1 times A2 plus B1 times B2 plus C1 times C2. So for the solution is we have to find OA first. So OA equal to 4i plus 7j negative 2k, and for the OB equal to 5i plus 3j plus 2k. We have to times 4 times 5 plus j 7 times 3 plus k negative 2 times 2. So we have to plus everything. 20 plus 21 plus negative 4, and we get 37. So the next question is find the area of interior in the building using area of parallelogram with h represented by the vector A equal to 9i minus 3j plus 10k and B equal to 11i plus 6j plus 7k. So the next is we have to make column I, J and K. So first column is we have to close I and take J and K, which is negative 3, 10, 6, 7 minus J we are closing, and take I and K, which is 9, 10, 11, 7 plus k, we are closing and take I and j, which is 9, -3, 11, and 6. So next we are going to times -3 times 7 minus 10 times 6 minus 9 times 7 minus 10 times 11 plus 9 times 6 -3 times 11, and we get the answer is -81, -47, and 87. When we get the answer, next step is we have to square root them. -81 square plus -47 square plus 87 square, and we get 60,339 unit square. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan bin Safar, metric number 01DKM21F1080. Now we continue about example number 3. If OP equal 5i plus 4j minus 2k and Q equal positive 6j plus 10k, find PQ. And solution is PQ equal PO plus OQ equal negative OP plus OQ equal negative open bracket 5i plus 4j minus 2k close bracket plus open bracket I plus 6j plus 10k close bracket equal negative 5i minus 4j plus 2k plus I plus 6j plus 10k, and the answer is equal negative 4i plus 2j plus 12k. Okay, and the last part is conclusion. From our study, we have concluded that vector and scalar are used to find the area of triangle and other shape. It can also be used to find area using only coordinates. Through this, vector and scalar can be used in many fields like airplane navigation, ship, satellite, and especially in the field of architecture. Indeed, there is much more we need to learn in this field, especially in field of architecture.